Anton Dormer, Kettering Middle School, 8th grade math teacher. This is Foundation of Algebra. And this is unprecedented in that I have to record this particular presentation due to the current situation. The date is Tuesday, March 18th, 2020, and this is for my Foundation of Algebra students. And we're talking about transformation. We're going to do some review in this short session, and then I'm going to put up some work on Google Classroom. You already have some work that has been given to you on your workbook. Okay. All right. So the question is here, what is transformation in math? You should be looking at the screen here. So in these lessons, we will learn the different types of transformation in math. It's called translation, reflection, rotation, dilation. Transformation involves moving an object from its original position to a new position. The object in the new position is called the image. I repeat that. Transformation involves moving an object from its original position to a new position. The object in the new position is called the image. Each point in the object is mapped to another point in the image. So let's take a look at this. The following figures show four types of transformation: translation, reflection, rotation, and dilation. And let's go ahead and take a look at this. When we talk about transformation, we're talking about the movement of object on a coordinate plane. Please look at where I have the cursor. So this particular object has been moved from here to here. Notice the shape and size of the object has not changed. This first here is object, and then when it's moved, it's called the image of the object. And this is called translation. So translation is a movement of an object on a coordinate plane from one place to another without changing its shape and size. Then you have what is called reflection. Reflection is just like looking into a mirror. That is your reflection. So you'll have the original object, as you can see with my cursor, and then it's reflected over a particular plane or a particular axis, and you get a mirror image of that particular object. Notice that the shape and size of that particular image has not changed. Then you have rotation. Okay, rotation is in essence moving a particular object on a center point. So you can move this particular object at a certain amount of degrees on point A, point B, point C, or you can take a coordinate point away from the image and then rotate it. Okay, so you can rotate from here to here, or you can rotate from here to here. Okay, and then the next one of the translations that we have, it's not translation, transformations that we have is called dilation. Okay, dilation is taking an object, making it bigger, or you could take that object and make it smaller. Okay, but it has relatively the same dimension, except for it is a bigger size. And we're going to go into more detail of what that is. So again, if you look at the definitions, we have this here. So in this lesson, we will study the following type of transformation math. One, translation, which involves the sliding of an object from one position to another. Reflection involves flipping an object over a line called a line of reflection. Rotation involving turning the object about a point called the center of rotation. And dilation involves the resizing of the object. It could result in an increase in size, enlargement, or a decrease in size, reduction. So the first three that I've talked about, translation, reflection, and rotation, these are called isometric transformation, in that the image is the same size and shape as the original object. So translation reflection, and rotations are called isometric transformation because the image is the same size and shape of the original object. And the original object and the image are congruent. Okay? And congruent means the same size, same shape. Dilations is not an isometric transformation because the size of the image is not the same as the object. The original object and the image are similar. They have the same shape but different sizes. Okay, today we're going to focus on translation. Tomorrow we're going to do reflection. The day after, we're going to do rotation. And then sometime next week, we'll deal with dilation. Okay, let's look at translation, just a little bit more details. Okay, so when we talk about translation, well, the object, of course, is to review what we have talked about in relationship to transformation. But in this particular lesson, in particular, we're going to look at translation transformation. So you will learn about what is translation, how translation can be represented by a column matrix or column vector, and how to translate points and shapes on the coordinate plane. Okay, let's go ahead and take a look at this. So what is translation? In a translation transformation, all the points and objects are moved in a straight line in the same direction. The size, the shape, and the orientation of the image are the same as that of the original object. Same orientation means that the object and the image are facing the same direction. For example, let's take a look at this. This is the object and this is the image of the object. Every point in the object is moved in the same direction and the same distance from to form the image. We describe a translation in terms of the number of units moved to the left, to the right, or the left, and the number of units moved up and down. Okay, and I should note before I go on that this particular lecture points, you can look at the URL on the top of the screen, and that will tell you where I'm getting this information from. So move the object 2 units to the right and 4 units up. This is how we do it. You take the object 2 units, 1, 2, and then move it up 4. 1, 2, 3, 4. And you should be able to do that with no problems. Okay? All right. So in this particular case, this is a little bit more detailed. Okay? So sometimes you could represent translation by a column vector or matrix. The translation can be represented by a column vector means 2, 4. What does that mean? That means that the top represents the right and left movement. A positive number means moving to the right, and a negative number means moving to the left. The bottom number represents the up and down movement. A positive number means moving up, and a negative number means moving down. So here, if you look at this particular figure, we have a triangle ABC is being translated to triangle A prime, B prime, C prime. Okay, this is your object, this is your image. Okay, and so this is represented by the vector 4 over 3. Okay, so 4, you can see that. Here is 1, 2, 3, 4. And then up 3, 1, 2, 3. Okay, so in general, a translation can be represented by a column matrix or column vector, where A is the number of units to move right or left along the x-axis, and B is the number of units to move up and down along the y-axis. Okay, so here the matrix equation represents the translation. You have A and B, as you can see here, and then X and Y along either XY, X-axis or Y-axis. and you have x prime and y prime. Okay, I think that's just amount of details that I want to go through in this particular case. Okay, and so that is talking about translation, and I will go ahead and do a few problems. Okay, again, we have translation on the coordinate plane. So you have what's called geometric translation. I'm going to touch this point before I leave. And a geometric translation is an isometric transmission, meaning that the original figure and image are congruent. Congruent means the same. Translating a figure can be thought as sliding the original. If the image moves left and down, the rule will be x negative minus whatever, y minus whatever, where the blanks are the distance moved along each axis. For translation left and up, you have x minus whatever unit, y plus. For right and down, it'd be x plus, y minus. Right and up, it'd be x plus, y plus. Okay. So here is a particular video. I probably will put that video on Google Docs so that you can see how that is done. So movement of translations. Okay, so we are done with our first lecture. And this will be put on Google Docs. And I will see you tomorrow when we will talk about rotations. Thank you and good day.